Okay, let's dive right into this explainer and unlock the absolute superpower of connecting your Flutter apps to the real world. If you've been building static screens up until now, it's time to take the training wheels completely off. Today, we're figuring out exactly how to make your app talk to live databases out there on the internet.
So, here's the million-dollar question. How does an app actually talk to the internet without totally freezing your phone? Well, what's really interesting here is that handling time delays properly is the absolute secret to a smooth professional application. Because think about it, if you don't handle those internet delays correctly, your app is just going to freeze solid while it waits for data, and your users, they'll just think it's broken. We're definitely going to fix that today.
We are going to conquer this intimidating topic step by step using a series of interconnected real-world analogies. Here is the game plan. 1. Futures in the coffee shop. 2. APIs and a waiter. 3. Get requests and couriers. 4. Displaying live data. And finally, 5. Post requests and shipping.
Section 1. Futures and the coffee shop. Let's start locally by managing time delays directly inside your app.
This right here brilliantly illustrates why asynchronous programming is so absolutely essential. Imagine a terrible, synchronous coffee shop. You order, and the cashier just completely freezes for 5 minutes while your coffee brews, right? The whole line is stuck behind you. But a smart, asynchronous cashier hands you an empty cup with your name on it, basically a receipt, and immediately takes the very next person's order. In Dart, that empty cup is quite literally called a future. It's just a promise that the data is going to arrive soon, which lets the rest of your app keep moving perfectly.
So the crucial point is using the async and await keywords to handle those empty cups. You slap async onto a function so Dart knows, hey, this is going to take some time. Then you drop await right in front of your slow internet request. This tells Dart to pause just that specific function and wait for the cup to fill. But, and this is key, it lets the rest of the application's user interface keep ticking along without freezing. But wait, how do we actually show the user that we're waiting for that cup to fill? Imagine a fast food digital order screen. In Flutter, that's your Future Builder widget. It constantly watches that empty cup future and automatically updates your screen through 3 distinct states. First, waiting, where we show a spinning circular progress indicator. Second, error, just in case the internet crashes. And third, done, where we instantly display that sweet downloaded data.
When you actually run this on a real phone, it's incredibly smooth. Thanks to the Future Builder, nobody is staring at a frozen screen. Instead, you see a beautiful purple spinner, and the exact millisecond the data arrives, boom, it dynamically swaps out the spinner for your featured item, like the luxury ocean suite.
Section 2. APIs and the waiter. Now that we know how to wait gracefully, let's learn how to actually ask the internet for real data.
Your app simply can't break into the database kitchen to grab data itself. It has to politely ask the REST API, which acts as our digital waiter. The waiter goes to the kitchen and brings your data back. But since your app speaks Dart and the server might speak Python, the waiter packs the food in a universal, super easy-to-read box labeled JSON.
Now, when you call that API waiter over, you have to tell them exactly what you want. Here are the 4 main commands you can give, and they map perfectly to standard CRUD operations. You've got get to read data, post to create a brand new record, put or patch to update something, and delete to, well, delete it. For this explainer, we're really focusing heavily on get and post.
To actually talk to the internet, we have to carefully write the HTTP package onto our pubspec.yaml shopping list. But a quick warning here, and I mean this, YAML files are ridiculously strict about spaces. You cannot use the tab key. The word HTTP has to line up perfectly using exact spacebar indentations, or your whole app will absolutely crash on you.
Section 3. Get requests and couriers. Let's move to our next analogy and see exactly how we fetch a list of hotel rooms.
Think of the http.get command as hiring a motorcycle courier. First, you format the web address into a precise URI coordinate. Second, the courier drives off, and since driving takes time, we use await. Third, the courier returns with a sealed response envelope. And finally, before you open it, you absolutely must check the stamp on the outside. A status code of 200 means, okay, the trip was a total success.
But here's the catch. Because raw JSON is basically just a giant paragraph of dumb text, we have to send it to the translation factory. We use JSON decode like a crowbar to rip open the text into a dictionary. Then we provide our model class blueprint and let our from JSON factory worker pull the raw materials and build a smart, perfectly organized Dart object. Your app can't do much with raw text, so this step is a total game changer. Section 4.
Displaying your live data. It's time to take those perfectly organized Dart objects and feed them right into our user interface.
Our hyper-efficient assembly line robot uses the .map command to translate an entire list of those raw JSON dictionaries into a neat list of smart Dart objects. Then it feeds that straight into a list view builder, instantly stamping out a massive, beautifully scrolling list of UI hotel cards. It is fast, efficient, and honestly pretty satisfying to watch.
Section 5. Post requests and shipping. Finally, what if the user actually wants to book a room and send data back to the server?
Notice the really clear contrast here. With a GET request, we're reading data, sending the courier out empty-handed. But with a POST request, we aren't reading anymore. We are handing that courier a completely sealed package of brand new data to drop off and create a fresh record in the database kitchen.
Now, servers are highly secure, kind of paranoid actually, so you absolutely must follow 2 shipping rules. First, pack the box using JSON encode to turn your Dart data back into universal JSON. And second, you have to slap a strict security shipping label called headers on the outside, specifically proving the content is safe application/JSON text.
And when you get it right, it's a beautiful thing. A successful POST request is incredibly smooth. The user types in their info, hits the button, and then you're instantly confirmed by a sleek green snap bar sliding up from the bottom of the screen, just like a waiter whispering that your room was successfully added.
So what incredible cross-platform app are you going to build now that you've officially conquered the internet? With async logic, APIs, JSON parsing, and HTTP requests completely mastered, the entire world of live data is literally right at your fingertips. Seriously, the sky is the limit here. Go build something amazing.